Hello students, welcome to a new lesson. We are going to turn to lesson 3 in our textbooks on page M335. We are working on equivalent expressions today. It's always a good idea, first of all, to look over that first page so you can look at the warm-up. Those are good practice problems for those of you looking for some more support. Learning goals, that's everything you're supposed to know by the time our lessons are through. And key terms, that's our vocabulary words. Those are things we're going to need to know as we go through the lesson. All right, so look that over, hit pause if you need to, and we are going to jump right in. We're going to skip the getting started. Go ahead and move on to page 38 and look where it's got activity 3.1. So we are going to use algebraic tiles to explore like terms. Now, terms we had in our notes the other day. We had a problem that looked like this, and we had to identify which ones were the terms. And we figured out, okay, well, there's 4 terms. 5a is a term, positive 3b is a term, negative 4c is a term, and 7 is a term. Each of them are separated by the addition or subtraction symbols. The variables are combined with their coefficient as one term, even though it's 2 numbers, they're together. All right, so this one has 4 terms. I'm going to use like terms. All right, so I'm sorry, skip down to M3, 38. Okay, we're looking at number 3. The paragraph above talks about an algebraic expression like terms are 2 or more terms that have the same variable raised to the same power. For example, if you look at number 3, you've got x squared, 2 of them. You've got x's, and you've got 1's. So in this example, you want to see what's the same. Those are our like terms. Those can be combined. If they're not the same, you cannot combine them. Coefficients of like terms can be different. And we're going to see that in a moment, okay? So, number 3, you have your algebraic model. Tiles. They represent things. You're going to write an addition expression that highlights the different tiles in the model, and then combine terms if you can. So I look at this and I say, okay, x squared, those are both the same. Those are like terms. I look and I say, okay, I have some x's, those I can combine, and I have some 1's, those I can combine as well. When you're making like terms, when you're combining anything, there are a few things you need to assume. The first thing you need to assume is that 1 is the coefficient if no number is there. All right, this is a good thing to remember. It might be something you put in the side of your textbook. The other thing you really want to assume and remember is if there is no symbol before your term, you always assume that that is a positive term or a plus term, right? That's really important to remember. So let's start with the 1's because the 1's are probably what is easiest right now. We have 4 1's, right? So I have 1 plus 1 plus 1 plus 1. That makes 4. So these are each my individual terms. The question said combine if necessary. So I have 1, 1, 1, 1. That makes 4. So this is one part of the algebraic expression. Now let's look at those x's. How many x's do you see? That's right, you've got 1, 2, 3 of them. So I write them out first. If I want to put a 1 there, sure, but I don't need to because like I said, I'm assuming there's a 1 if there's no coefficient present. 1, 2, 3, I have 3 x's. Remember, 3 next to an x means multiplied, so 3 times x, 3 x's. And then we've got our x squareds. So we have how many x squareds? That's right, we've got 2x squareds. Add together, we've got 2x squared. You put it all together and you end up with what? Write it on your page. All three of those terms in one algebraic expression. Did you get an answer? You should have written 2x squared plus 3x plus 4. Technically, you want to list your variables in the order of powers. So it's not wrong to have 3x first, it's just not right. So whenever you're listing terms and you've got exponents and you've got variables, you want to list the highest power first and go down from there, finally ending if there is no variable. Okay? Just a little tip. Let's move to page 39. So go to the next page. And we've got number 7 at the bottom. We skipped a lot of questions. Those are really good for you to go practice on your own, all right? So, number 7, it says, use what you have learned about combining like terms to rewrite each algebraic expression with as few terms as possible. So we're going to look at A first. We have 2x plus 3x minus 4 and 5/10 x. And we need to think, which are the like terms? What can I combine? What is the same? What variables are the same? The coefficients can be different. I'm looking for variables or no variables. So I look at this problem and I say, okay, I see a 2x and I'm going to circle it. I see a positive 3x. I'm going to circle that. Remember to circle the positive. I have a negative 4.5x. Remember to circle the negative. So now I'm going to write them all out together. I lined them up this way because it's easier for me. So I have 2 plus 3 plus 4.5, and I have x's next to them, right? Well, I need to line up my decimals. 2 and 3 don't have a decimal because it's hiding. So I have 2.0, 3.0, and 4.5x. Add those all together, and you get 9.5. Make sure you got it. Let's look at the next one, B. Again, we're going to look at our expression and we're going to say which are our like terms. Which ones can I combine? 3 and 1/2 y plus 2 plus 4y plus 1 and 1/4. Alright, this one's a little trickier. I have some variables. I have 2 of the same variable. And then I've got some constants. I have no variable with 2 and with 1 and 1/4. So let's combine what we can. I circled the 3 and 1/2 y. I circled the 4y. I put a square around the 2 and around the 1 and 1/4. The shapes help me recognize my individual terms. It might be a good idea for you to do the same. So I'm going to add up my variables first. I have 3.5 plus 4. Well, 3 and 4 make 7.5 y. Then I'm going to add my constants. So I have 2 plus 1/4. Well, that's 3 and 1/4. Since they were both positive, I can add them together, and my final expression is 7.5 y plus 3 and 1/4. Remember, I list the variable first and the constant last. All right, we're going to try one more. If I'm going too fast, remember, you should be pausing, you should be copying, you should be understanding. If it doesn't make sense, go back and repeat. C. All right, C is 4.5x plus 6y minus 3.5x plus 7. Again, which are the like terms? What do I need to combine? Do you think you know? Hit pause and figure it out on your own, then hit play again. All right, you got your answer? You've combined what you think you should be? Here's what I combined. I have 4.5x circled and negative 3.5x. Those are both circled, so I'm going to combine them. Before I was adding, well, negative 3.5 is minus, so I'm going to subtract, and I end up with 1. x. I'm sorry, I end up with 1x. Now I've got positive 6y. Well, I don't have any like terms for that, so I'm just going to put plus 6y. And I'm left with plus 7. There's no other constants. 7 cannot be combined with 6y, so 7's going to be left on its own too. Notice how my x could not go with my y could not go with my x, and neither variable could go with my constant. That's very important. Got it? We're going to skip, but the rest of those problems, D and E, would be a great thing for you to practice on your own time. Let's go on to page 344. I know that's skipping a couple of pages. All right. We are going to talk about the distributive property. Okay. So